We are going to see another EC, PC, Lemons QC chapter, which is D and F block. So whatever the questions are coming from P block, D and F block on coordination compounds, you can just read the question, tick the right answer, get your marks. That's it. There is no other fancy mechanisms, thinking a lot about the reagents, nothing is there. These are the easiest to mark you can get for your examination. First, let's go into what are D block and F block elements. Before getting into that, I would like to tell you a little surprise for you, whoever watches the video till the end. I'm going to give you an important announcement. It's in the middle of the video, so please watch it carefully. This session will be very useful to you, because we are going to cover lot more things about D and F block elements along with the previous year questions. Okay, so what are D block elements? D block elements are the one which are residing here. The valence electrons are D subshell, right? So what about F block elements? Whenever the electron goes to F subshell, then that is F block elements. They are lanthanides and actinides. Okay, why F block elements are called inner transition elements? Because they are inside the series, like from 57 to 70, which should be placed over here, and 89 to 102, which should be placed over here. But since they are not having the common property with the transition elements, we are just placing it just below the entire periodic table. Okay, so let's talk about D block elements first. Here in the D block, as I told you, the electronic configuration, they are having incompletely filled d orbitals, leading to the unique properties. Across the period, atomic and ionic radii decreases due to the increase in nuclear charge, and down the group it increases because increase in number of shells. Density and hardness increases with the number of atomic number due to the strong metallic bonding. These transition elements are metallic in nature. Don't think about non-metal at all. Okay, these are metallic in nature. And talking about the oxidation states, they exhibit various oxidation states because the participation of both N-1d as well as Ns electrons are in the bonding. They are acting as a valence shell. For example, if I am taking scandium, that would be the stable oxidation state would be +3. Titanium is having varying oxidation state from +2 to +4. Manganese +2 to +7. And iron +2, 1, +3. Ferrous and ferric. Copper, cuprous and cupric. So like this, it will exhibit varying oxidation states. Okay. As I told you, these are metallic in nature. So which means what kind of structure it will opt, what kind of close packing. These exhibit metallic bonding due to their hexagonal close packed, cubic close packed or body centered cubic crystal lattices. This bonding arises from the presence of one or more electrons in an outermost energy levels, that is Ns, and an unpaired d orbital electrons as well. Okay, and talking about ionization energies, as we all know, ionization energy generally increases with atomic number because of the effective nuclear charge. But here it is not following a regular pattern. For 5D elements, the ionization energies are higher compared to 4D and 3D elements because of greater effective nuclear charge it causes a poor shielding of d orbitals, sorry, f orbitals. That's why 5d elements are having more ionization energy, require more energy to remove an electron from the atom than the 4d and 3d elements because of poor shielding of 4f electrons. The next one is electrode potential. The standard electrode potential, it depends on these three factors: heat of sublimation, heat of ionization, and hydration. The first thing, heat of sublimation. What will happen? It is an energy required to convert the solid metal to its gaseous atom. So in that case, the standard electrode potential differs, and also heat of ionization. When we are removing the electrons from the gaseous metal atoms to form ions, there also the electrode potential varies. And then heat of hydration, the energy released when a gaseous metal ions dissolve in water to form hydrated ions. So in these cases, for the 3D transition metals, E0 M 2 plus 2 M, this kind of values getting changed. These are following an irregular trend which is due to the variation in ionization energies and sublimation energies. Except copper in 3D elements are good reducing agent but weaker than S block elements. But whenever they're asking questions about copper, please be careful with that. Then high metallic and melting and boiling points. The transition elements obviously will have high melting and boiling points because they are strong. They are having strong metallic bonds. This melting point initially increases with atomic number. It reaches the peak and then decreases as the atomic number rises further. So the question can be asked, which of the following is true? Which of the following is incorrect? Which of the following statement is correct about melting and boiling points? There you have to remember the melting point of the transition element. First that will rise and reaches the maximum. Then it will fall as the atomic number increases. And most importantly, these elements, transition elements, tend to form complexes. Why is it so? Because of the availability of vacant d orbitals and smaller atomic size and high charge density. These three are the important factors why these transition elements and inner transition elements tend to form n number of complexes. Talking about magnetic properties. Usually these kind of questions, magnetic property kind of questions, will be asked combined with the coordination complexes chapter. Next we are going to deal with that chapter, but here I am going to give you the formula for finding out the magnetic property. The paramagnetic substances will be owing the unpaired electrons, isn't it? Diamagnetic means all are paired, paramagnetic is having the unpaired electrons. So here the magnetic moment you can find by using the formula mu s, the spin only magnetic moment, that stands for S, is root of n into n plus 2 Bohr magneton. That is the formula to find out the magnetic moment. Questions can be asked from this part. Mostly they'll ask then the combined level with coordination chemistry as well. So here the n represents number of unpaired electrons. Then the next important property is alloy formation. These are forming alloys, like for example silver is forming lots of alloys, and then copper what not, many other elements in the transition series are formed alloys which are having very good commercial uses. Interstitial compounds. Interstitial compounds are nothing but, in the solid state chapter we talked about, in the in-between space some atoms will get occupied because of the smaller size. That's what the interstitial compounds are. So these tend to form an interstitial compounds. Then we are going to see the nature of transition metal oxides. In the P block element also I told you the questions can be asked in the way acidic, basic and amphoteric oxides. Right. So here you can see scandium is forming basic oxide, titanium basic oxide as well as amphoteric, which is TiO2, where the titanium is in +4 oxidation state, and vanadium, VO, V2O3 are basic, and amphoteric is VO2, acidic is V2O5. Similarly, I have listed all those oxides according to the basic, amphoteric and acidic. So point to be noted here is, whenever they are giving some oxides and asking you to find which category that lies in. Vanadium, chromium, manganese, 23 atomic number, 24 and 25. These set only forms acidic. The acidic category, these 3 atoms can form. Amphoteric means 1 extra. Take titanium as well. Remaining all the oxides which they are giving, those are basic. Okay. Then the relationship between oxidation number and acidity. The most important question can be asked from manganese, because manganese can form varying oxidation state. Starting from +2, it can form up to +7 also. So we have to note it down, these oxides which are having different category, like MnO is basic in nature, Mn3O4, where the oxidation state is +5, and then MnO2, where +4 oxidation state. These two are amphoteric in nature. +7 oxidation state. Usually higher oxidation states are acidic in nature. You can see that in above table also. And basic are MnO, +2 oxidation state. Okay. Acidic strength of oxides of a transition metal increases with increase in oxidation number. Point to be noted. Okay. So that's it about the oxidation state. And then color of D block elements. In last January paper also, they have asked some questions in color. The table which in your NCERT book, which is very important, just memorize those colors. If you want the mnemonic, just put it on the comment. Just inform me. I'll post the mnemonics for everything. Okay. Then color of the D block elements. Why they are forming colors? First of all, the first reason would be due to the d-d transitions. D orbital to d orbital transitions within the partially filled d orbitals. That is the first reason. And how the color can be formed is that whatever the color we are seeing, that is the complementary color of the observed wavelength. Okay. So what is that complementary and absorption? What is that? So usually there is a color wheel. I think most of you must have heard about it, but I am giving you the simple trick to remember the color wheel. The first you have to know the Vidyar, the basic colors. Right. So let me take a wheel where I'm just going to give only the 6 colors, not those 7 colors. Vidyar, violet, indigo, blue, green, yellow, orange, red. So I'm going to write violet, indigo, green, yellow, orange, red. In the same order, I'm just going to leave blue. Blue and indigo both are the same colors. Now we just remember it like that. So just I'm eliminating blue. So this is the color wheel. So if the absorption wavelength lies in the violet color, then we can see the color of yellow, just the opposite one. If the absorption wavelength is in indigo, orange would be the color you are seeing. If green is there, then red. Red is there, red is the absorbed wavelength, then you will be seeing the color green. That is the nature of the color, what light it got absorbed and what we are seeing. Okay. And color is because of DD transition. But there are some other reason also. We are going to see KMNO4 and potassium dichromate. We'll see the properties there. Here the list of some D block elements, which is color. As I told you, the colorless ions which are having no unpaired electrons, and hence there is no DD transitions can occur. And the observed color, which should be the complementary color of the observed light. That's more important. So some questions can be asked like this. They will give you the wavelength and they will give you the color of observed wavelength and ask you to find what would be the color of the compound. Okay, in that case the color wheel will be very much useful to you. So now we are moving on to potassium dichromate. In your syllabus, potassium dichromate and potassium permanganate, which plays an important role, because these two compounds are having n number of applications in synthetic organic chemistry, in inorganic as well. This is a very good oxidizing agent. So why this is a very good oxidizing agent? Because oxidizing agent means it itself reduces. Right, reduction is gain of electron. So gain of electron means it should have a deficiency so that it can gain. Right. So in these compounds K2Cr2O7, KMNO4, there the chromium and manganese are in the higher oxidation state position. Here the chromium is in +6 oxidation state. And KMNO4 you can see manganese is in +7 oxidation state. So which can reduce itself to the lower oxidation state so that it can act as an oxidizing agent for others. And how to prepare these compounds? The preparation starts from using iron chromate compound to produce sodium chromate and Fe2O3 carbon dioxide. If I am taking sodium chromate with H2SO4, it is giving sodium dichromate, and dichromate with KCl, it is giving us potassium dichromate. So potassium dichromate is in orange color, the bright orange color, so which you can easily see in your lab. Then the structure of dichromate. The question can be asked from the structure also. As you can see, it is in Cr2O7 2-, right? So the structure is tetrahedral of CrO4, which should be like this. Minus one O. The one oxygen will be shared over here between two Cr complex. So this is the structure of Cr2O7 2- and 2K plus will be there in the outside. Okay, and the angle is approximately 126 degrees of this angle. Each chromium atom is surrounded by the 4 oxygen atoms in a tetrahedral arrangement. Okay, so what are the properties it can exhibit? I told you that is a orangish red, red crystalline compound, and moderately soluble in cold water, freely soluble in hot water. Talking about the chemical properties, it undergoes thermal decomposition. It reacts with alkali to form chromate compound, that is K2CrO4, and chromate to dichromate, which maintains a interconvertible equilibrium stage. Depending on the pH, it changes. Chromate, which is in yellow color, and dichromate, which would be in orangish red. The brighter it becomes. So it maintains the equilibrium, which is represented here. And I told you it is a very good oxidizing agent because of its higher oxidation state. Then we are moving on to potassium permanganate. Potassium permanganate, which is in purple in color, manganese, that is in +7 oxidation state here. It can be prepared by using potassium manganate with H2SO4, which gives permanganate, and it undergoes a disproportionation reaction where it gives +4 and +6 oxidation state. And the structure of permanganate ion MnO4 is again the tetrahedral geometry, which will look like this. Should be looking like a tetrahedral geometry, and the manganese is either sp3 or sd3 hybridized. It can be considered as a mixture of these two hybridization. The questions can be asked from this part. What is the hybridization of manganese in permanganate? So that is an important question. Then, talking about the properties. It is a dark purple crystalline solid and moderately soluble in water, forming a purple solution. The solubility increases with temperature. And the thermal decomposition, it decomposes at 200 degrees Celsius. K1O4 gives K2MnO4 plus MnO2. The reaction with alkalis, it decomposes upon heating with alkalis, which will give again K2MnO4 manganate ions. In the oxidation nature, as I told you, it is a very good oxidizing agent. In acidic medium, observe the oxidation changes. Okay, from which state to which state it is changing. MnO4 minus to Mn2 plus in acidic medium. In case of alkaline medium, MnO4 minus to Mn plus 4 oxidation state. These are the important points to be noted. This part can be combined with the mole concept chapter, which can be asked in a JEE Advanced question. Okay, in alkaline medium, this is a reaction happens. So, find out the product. So how much it is yield would be. So that kind of reaction you can expect. Questions you can expect. To see F block elements, which is also known as inner transition elements. This consists of two series. One is lanthanide, another one is actinides. Right? Each has these having 14 elements each. First, let's talk about lanthanides. From lanthanum to lutetium, elements are called lanthanides, where the outer electronic configurations are 4f1 to 14, 5d0 to 1, and 6s2. So the electronic configuration is also important. This can be asked as a simple question. Then the element details are lanthanum, cerium, prometherium, neodymium, praseodymium, samarium, europium, gadolinium, terbium, and so on. And the common oxidation state of lanthanide series is +3 oxidation state, but it varies from +2 to +4. Okay, the most important concept in lanthanide series is that lanthanide contraction. What is that? Contraction means shrinking. It is becoming small. So lanthanide contraction means the decrease in size of atoms and ions with increase in atomic number in the throughout lanthanide series. That's what the lanthanide contraction is, which will result in the poor shielding effect of F electrons, F subshell electrons. So that what will happen? It will decrease the basic strength of oxides, and the chemical properties will be similar throughout the series, and the slight increase in electronegativity for the trivalent 3+ ions and small increase in standard electrode potential values from lanthanide to lutetium series. So what is lanthanide contraction and what it affects? So those are important. There is a decrease in basic strength of oxides and hydroxide, the most important point. Why is it happening? It is because of it creates a poor shielding effect of F subshell electrons. The physical effects includes decrease in atomic and ionic radii, increase in density, increase in melting and boiling points, and enhanced metallic character. Other than this, what are the general properties of actinide? Lanthanides are having the oxidation state +2 to +4, and the common one is +3. Similarly, it will have low ionization energies. If I am talking about color, it will exhibit color unless or until it is having the completely filled orbitals. Completely filled means there is no transition, so it becomes colorless. In lanthanide series, other than 4F0 type, that means lanthanum 3+ and cerium 4+, and 4F14 type like ytterbium 2+, lutetium 3+, these are paramagnetic. They are having single unpaired electrons. This paramagnetic rises to the second maximum at gadolinium before falling to the 0 at the end of the series. That's it about the magnetic property of lanthanides. It can undergo reactions with oxygen, sulfur, halogens, and the corresponding compound it will result in. With acid also it will release H2 gas. Okay, talking about actinides which are having the common electronic configuration, it is 4F1 to 14, 6D0 to 1, 7S2. And the central properties of actinides are, they also exhibit the multiple oxidation states. The common one is +4 oxidation state. It do exhibit +2 to +4, and the transition element similarity. Some actinides show the great resemblance with the elements of the transition series. Okay, for example, thorium shows a stable oxidation state of +4, behaves like a group 4 element. and uranium exhibits oxidation state of +6, and which resembles the group 6. +3 oxidation state in the actinides becomes increasingly stable as the atomic number increases. Talking about color and paramagnetism, U4 plus is green in color, U3 plus which is red in color. These two are very important colors of actinide series. And magnetic behavior, cations and of actinides containing only paired electrons, which means they are diamagnetic in nature. All of the ions with unpaired 5f electrons are becoming paramagnetic. Ionic size, here also the actinide contraction happens because it will lead to poor shielding of 5f electrons. The ionic radii of trivalent cations decreases regularly with increase in atomic number across the series. The reason of color here, that is relevant to FF transition. In D block elements in transition series, we talked about DD transition, that is the responsible for color. Here this is FF transition. Since F electrons are deeply buried inside the atom, the energy gaps between F electrons, F orbital electrons are smaller. So the color is weaker compared to the transition metals. Some questions can be asked from here also. What about the color? Why the colors are dull in case of these series compared to transition elements? So please be careful with that. What are the difference between lanthanides and actinides? The first difference with the oxidation state. Beside +3, it shows +4, +5, +6, +7 also in case of actinides. Lanthanides exhibit +4, +2, +3 only. Except prometheium, they are non-radioactive. All actinides are radioactive. They do not form oxo ions. They form oxo ions like uranium oxide, which is having the charge of 2+, and plutonium oxide, which is having the charge of 2+, and uranium oxide, that is having the charge of +. So these are oxo and ions of actinides, but in case of lanthanides, they don't form oxo ions. The compounds of lanthanides are less basic. The actinide compounds are becoming more and more basic. They have less tendency of complex formation, but here actinides can form complexes quite easily. Apart from these, whatever we have discussed, we do have some other important points about transition and inner transition elements that I am including in the material also. So people who were aiming for advanced, you can go through this. Even for main, the tough questions can be asked from this part. So just go through it. I am attaching it here. Most importantly, Wilkinson catalyst. So Wilkinson catalyst, which is of rhodium based catalyst, which is used for the hydrogenation of alkenes. That point is very much important. Apart from this, oxidation state we know. The biological importance of transition elements. Iron, which is present in hemoglobin. Hemoglobin is responsible for oxygen transport in blood. Copper, which is present in plastocyanin in plants, and then hemocyanin. Cobalt, which is in vitamin B12. Zinc, that is in carbonic anhydrase. These are the biological importance of transition elements. Apart from that, which is used in metallurgical purposes for the extraction of metals. Annealing process, tempering process, where the transition elements are used. metal extraction as well as the purification purposes. Lanthionine serves as a catalyst in hydrogenation, dehydrogenation and etc. In case of medical use, some radioactive elements like iodine 131, which is used in a thyroid treatment, and Gopal 60, which is used in a cancer treatment. Thorium salts are also used in the cancer treatment. Transition and non-transition elements are very much used in the medical purposes. And I have told you there is a little surprise for you guys who will watch this video till the end, which is that here I am attaching the series of previous year papers you to attempt, because the exams are going to come in less than a month. So you have to prepare for this. Preparing means not revising the concept only, revising plus practice, which is more important. Always, as I'm always saying, practice is more important than revising the concept. Okay? So I'm attaching the link of all those previous year questions of JEE Main, NEET, Advanced and other competitive exams as well. 4 links I will be providing in the description or in the first comment. So please make use of it. The solutions are also given along with the question. So attempt it and check your answers and improve your quality of response. Now this question, which is asked in JEE Main 2019, very simplistic question. Here I am going to tell you a trick, which is that they are asking for the magnetic moment. Okay, the first thing first, you have to count the unpaired electrons. So if I are counting the unpaired electrons of manganese 2 plus, the electronic configuration 3d5 4 is 0, and chromium 3 plus, in ground state chromium will be 3d5 4 is 1, and chromium 3 plus, which is 3d3 4 is 0, and Fe2 plus, in ground state Fe is 3d6 4 is 2, here 3d6 4 is 0, and titanium 3 plus, which will be 3d2 4 is 2, here it becomes 3d1 4 is 0. Here you can see 5, 3, and then how many unpaired electrons? 4 over here, then comes 1. If they are asking the BM values, also just have these unpaired electrons count, then your problem is sorted. Mostly the number of unpaired electrons, which is almost equal to the BM value. For example, if I am calculating the BM value for 3d5, 5 unpaired electrons. So root of 5 into 5 plus 2, n into n plus 1 BM, right? So 5 into 5 plus 2, 7. So total it became root 35. Root 35, which is nothing but 5.92. So which is almost the first decimal point, the first number before the decimal point, that is equal to the unpaired electron. So taking use of it, the correct answer to this question is option D. Then the next question, the oxidation state of chromium in K3Cr(C2O4) thrice. I told you this kind of question can be combined with the coordination complex questions. Say for example, here they are asking about the oxidation state of chromium, isn't it? So this is a complex. I am taking K3, which is having a oxidation state, potassium oxidation state is always 1 plus 1, and then C2O4 oxalate, so the oxidation state is -2. So 3 into plus 1 plus X for chromium, and then 3 into -2, which is equal to overall charge is 0. Then plus X minus 6, which is equal to 0, X is equal to plus 6 minus 3. So X becomes plus 3. And what about the second complex? 2 into plus 1 plus X. For oxygen, that is minus 2. So 4 oxygens are there. 4 into minus 2, 8. So 2 plus X minus 8 equal to 0. X is equal to plus 8 minus 2 plus 6. So answer to this question becomes plus 3 and plus 6. Option B is the right answer to this question. Then the simplest question asked in JEE Advanced. Among the following, the number of compound that liberate CO2 on treatment with dilute acid is. So potassium carbonate with HCl, it's liberate, carbonate is there, no? So it liberates CO2. Okay. And then what about sodium peroxide? Which is HCl, it will produce NaCl and peroxide, hydrogen peroxide. So it will not. Then what about iron carbonate? Iron carbonate, it will liberate CO2. What about barium peroxide? Again, hydrogen peroxide will be produced. Calcium oxide, no. Calcium chloride and H2O will be produced. What about manganese oxide? In case of manganese oxide also, it will not produce any CO2 gas. Very simple question. If the CO2 is there in the compound, it will release because that is reacting with the dilute acid, isn't it? So answer to this question is 2. The next question, identify the correct statement from the following. Lanthanide contraction is responsible for the fact that atomic radii of zirconium and hafnium are almost identical. Okay. The actinides exhibit more oxidation states than lanthanides. In the lanthanide series, the ionic radius of europium 2+ is larger than lanthanum 3+. Lanthanides form colored ions because of partly filled d orbitals. Which of the following is right? The first thing first, the lanthanide contraction is responsible for the fact zirconium and hafnium is almost, atomic sizes are almost equal, right? And then the second fact, actinides exhibit more oxidation state than lanthanide. Yes, of course. +4 oxidation state, +7 oxidation state also it can exhibit. And then in the lanthanide series, ionic radii of europium 2+ is larger than lanthanum 3+. That is also true. Europium 2+ has half-filled f orbital, providing a extra stability, and the effective nuclear charge, due to the decreased effective nuclear charge, it is becoming bigger. That is also true. And the final option, lanthanides form colored ions because of partly filled f orbitals. That is also true. So all 4 is true. Answer to this question is A, B, C, D. It is a multiple select question. Then, which of the following statements is correct? Cerium 4+ ion is a good oxidizing agent. Europium 2+ ion is good reducing agent. Magnetic moment of gadolinium 3+ is higher than that of europium 3+. The basicity of lanthanum hydroxide decreases from lanthanum to lutetium. Okay, the first one, which is a good oxidizing agent, because it can exhibit +2 oxidation state also, +3 and +4. It can get reduced. Okay, first statement is true. What about the second one? Europium is a good reducing agent. This is also correct because it is having the oxidation state of +2, +3 as well. So it itself can oxidize. Then magnetic moment of gadolinium 3 plus is higher than europium 3 plus. By using the values, gadolinium, which is having 7 unpaired electrons, it is a half-filled F orbital, and europium, that is having europium 3 plus, is having 6 unpaired electrons. So which will have more magnetic moment? Of course, gadolinium. So that is also a true statement. Then basicity of lanthanide's hydroxide decreases from lanthanide to lutetium. It is because of our lanthanide contraction. That is also true. So all 4 options are true. Then this question, manganese O4 minus reacts with SO2 in acidic medium. The oxidation state of Mn changes from. So what happens here? MnO4 minus plus 5SO2 plus H2O. The reaction is Mn2 plus 5SO4 2 minus plus 4H plus. Right. So here you can see the oxidation state of manganese in the reactant side, that is plus 7, that is getting changed to plus 2 oxidation state, which clearly shows that option A is the right answer to this question. You can easily omit option D and C by finding the oxidation state of Mn. So only thing you have to know, in acidic medium what is the change. I have given the reactions also, right? In KMnO4, in alkaline medium what is the change, and acidic medium what is the change. Okay, that's it for today, guys. Next chapter will be the coordination complex. Please practice more questions. I'll be posting the previous year package along with this video. For the upcoming videos also will be posted the question bank. Please make wise use of it. Thank you.